All right, everybody. Thank you for joining us. We are looking forward to having a fun day today. We're going to take a tour of the National Weather Center, which is located in Norman, Oklahoma. I am so excited. I see one of our other schools is just joining us
There you
right now,
go.
so that is great. As soon as they get settled in, we're going to go around and introduce everybody. Real quickly for everybody, my name is Tim Bryce. I am a meteorologist with the National Weather Service in El Paso, Texas. And actually taking us, I'm going to be your host today, and actually taking us on the tour will be Mr. Pat Highland. He is let me make sure I read this right. He's the coordinator of external relations, or as he likes to say, the director of fun. How you doing
The
today,
director
Pat?
of fun. Oh, I'm doing awesome today. We just had a cold front come through. So, it's in our state song, Wind Comes Sweeping Down the Plain. Just another day in Oklahoma here.
Very good. So, joining us on the call today in the Hangout, I see we've got several people watching us on YouTube, which is great. I'm so glad you could join us. But in the Hangout today is Mr. O'Brien's class there in Middleborough, Massachusetts. How are you guys there doing? Very good. I'll ask you, is it warm or cold there? I know. I'm kidding. All right. And then in our other class right now, joining us is, let's see, Miss Powers' class in Genoa City, Wisconsin. They're at Brookwood Middle School. So, guys, thanks for joining us. We are looking forward to having a great time with you. I want to show you a map of where everybody is. Now, we're supposed to have two other schools, and I hope they can jump in here in a little bit. But you can see on the map there, we've got, I'm in El Paso, Texas, which is there in West Texas. Pat is in Norman, Oklahoma, where the National Weather Center is. We've got Miss Powers' class up there in Genoa City in southern Wisconsin, and we've got the people, the students over there in Mr. O'Brien's class in Middleborough, Massachusetts. And hopefully we can get one of our other classes is there in Ennis, Texas, and we had another class signed up for Mesa, Arizona. So hopefully they can get in here. I did real quickly wanted to show everybody what the temperatures are across the United States. I grabbed this from the Oklahoma Mesonet, which, Pat, correct me, they're located there in the National Weather Center there, aren't they?
They are. Yep. Their office is up on the second floor. And then all the data collected by all of our weather observation stations in Oklahoma go up to the third floor right by our server room.
Very good. So I wanted to real quickly show everybody what the temperature was, and then we will start the tour. But basically, it's pretty cold out there for a lot of people. For you guys there in Genoa City, it's right around freezing. It's only a little bit warmer there in Middleborough. Pat just had a cold front come through, so it was 57 degrees. Do you know what the temperature is right now, Pat?
I don't know. It was 67 degrees when I woke up at 6:30 this morning. I'm kind of afraid for you to tell me what the temperature is right now.
It was 57 an hour ago. But my guess is, since you said the cold front came through, it's a little cooler. Here in El Paso, it's 66, and we're going for a high today of 80. So I think
Everybody say boo.
We're going to be the winner for today. So, all right, I'm going to hand things over to Mr. Pat, and he's going to walk us around the atrium of the National Weather Center and show us some of the things that are in there. When he gets to a couple spots, we'll stop and we'll see if you guys want to ask some questions.
All right. So good morning, everybody. My name is Pat Highland. I work at the National Weather Center, the one and only National Weather Center here at the University of Oklahoma. Our building is really cool. We can have over 500 people inside our building at all times. So right now, students are upstairs on the 5th floor taking classes. There's some classroom space down here on the 1st floor. We've got people working for the federal government who are here. So folks like Tim at the El Paso Weather Service office, we've got a weather service office here too. We have the Storm Prediction Center here in our building too. They issue all the severe thunderstorm and tornado watches for the lower 48. And then we have people like the Oklahoma Climate Survey who are operating the Mesonet and collecting weather observations across Oklahoma. So a lot of different people here in our building. And it's a really cool building. If you guys ever get a chance to come to Norman, to Oklahoma, make sure that you stop by the National Weather Center and see it. So I'm going to take you on a little tour here of the atrium area so you can see what we've got. Right behind me is one of the showstoppers that we have here in the building. This is Science on a Sphere. This is really, really cool. This is a global display system. It's a 30-pound fiberglass sphere. It's about 6 feet in diameter. And we've got 4 projectors. You can see the projectors that are around here. And they're showing a portion of the image onto this globe surface. And then it's at the seams where we're kind of stitching it together to make it look like it's one image. So this thing is, it almost looks like a hologram, like sitting here in our atrium. So right now you're looking at, this is one of the models, the weather prediction models that we use to figure out what's going to happen in different parts of the world over about 2 weeks or so. This is the Global Forecast System model, or GFS. So this is just showing you where the potential for rain and precipitation is over the next over the next couple of weeks or so. So this is really cool. We can show atmospheric data. We can show ocean data. This thing can be the Death Star. It can be a fishbowl. It could be a disco ball. Lots of really cool stuff. If you guys want to play with this at home, you can go to sos.noaa.gov and download SOS Explorer Lite. It's a free desktop version of this. So sos.noaa.gov. I know your teachers are writing that down right now on their piece of paper. So sos.noaa.gov. So that's great. So we've got that here in our atrium. The other thing we have is, this is our weather wall. We've got 9 46-inch flat screen TVs here, so we could show lots of different types of weather information. So you see we've got the Weather Channel up there right now, and then we've got some graphics surrounding that Weather Channel broadcast. And then we've got, this gives us the ability to have classes down here too, so you don't have to be stuck in one of the 5th floor classes. You can come down here and teachers can plug their laptops in and have classes going on. We also, guys, we play video games on this thing. You can plug in any of the gaming systems that you have and you can play video games up here on our weather wall. So it's very, very cool. So that's down here in our atrium. One other thing we have down here in our atrium that I want to show you before we take some questions. Have you guys ever seen the movie Twister before? All right, if you haven't seen Twister, it's basically on TV like every day of the week on every TV station. You can see it really easily. We have some movie stars here in our building. So if you guys have ever seen the movie Twister before, here I'll show you a little poster up here. So that was the movie Twister. So it had Bill Paxton and Helen Hunt in it. These are the props from the movie Twister. So we've got Dorothy here. So this is one of the movie props. So that was Bill Paxton and Helen Hunt's group. Those were the good guys. They were doing it for the science. They were trying to figure out what was happening inside those tornadoes. And then this was the one. This is Dot 3. This is from the evil Jonas and his group. They were driving around the black minivans and SUVs. They were in it for the money and not for the science. So those are the props from the movie Twister. A lot of people ask us, where did they come up with an idea for the movie Twister? The movie Twister is actually inspired by this instrument right here, and the name of this instrument is TOTO. This is the Total Tornado Observatory. So this was an actual project by the National Severe Storms Lab, which is with NOAA, the federal government. They're here in the building. They were trying to put this in the path of a tornado so that they could figure out exactly what was happening inside those tornadoes. Now, as you can see, we didn't have little cool sensors with pop cans attached to them inside our barrel to get measurements. We use these instruments here on top. So we've got a cup anemometer here to get our wind speed. And then we've got this device here. This is a hygrometer. It measures temperature and relative humidity. And then we were able to get our pressure measurements from these little plates. Sorry, the little ferns blocking that there. So we've got our pressure measurements from each of those. So unfortunately, we never got this inside a tornado because a tornado's track can change really quickly. And it can go a different direction than what we think it's going to. And this doesn't take up a lot of space. It only takes up about 4 square feet. So it's really hard to pinpoint exactly where a tornado is going to go to next. And this was the only one. So we didn't have a whole bunch of them to take a look at tornadoes. So people got a little bit smarter with this. They started developing pods and stick nets that were smaller and more mobile and transportable so they could figure out exactly what was happening. And then you could set them up in a network. So if a tornado passed over a roadway, it might hit any one of those. And one thing that we're doing here at OU now, we're kind of evolving from TOTO here. We opened up a drone weather research group called the Center for Autonomous Sensing and Sampling. So we're going to be flying drones into the atmosphere so we can figure out exactly what's happening, what those ingredients look like for severe weather. So we have a lot of people here. We were the reason why there's a movie Twister. So we holds a really close place to our hearts. We love it so much. We love Twister so much that we had a cafe space installed here in the building. What do you think we called our cafe space, guys?
I know.
Called it the Flying Cow Cafe. Yes. So we've got a cafe here in the Weather Center, and this is open from 7:30 to 3 Monday through Friday. So people are in there having breakfast and lunch. So yeah, we love Twister so much we named our cafe space after it. So that's a little bit of a walk around our atrium area. We've got lots of stuff here in the building. As you can see, we've got 5 floors of office and classroom space here at the Weather Center, so a lot of territory. And we have an observation deck upstairs. So I'll show you some of these things as we go around today, but I'm going to toss it to you guys and to Tim to see if you guys have any questions at all.
I'll throw out the first question, Pat, and then I'll have one of the couple of classes ask a question real quickly. Why is it why are you doing research on tornadoes? We have radars and things. Why do they need to get instruments and things like that? Try to get them into the tornado or something in the path of a tornado.
That's a really good question because a lot of people think that we've got all of the stuff that we need to know about tornadoes, but there's still a lot of questions about tornadoes that we still have. And one of the worst sampled areas of our atmosphere is from the ground up to about 3,000 feet. That's called the boundary layer. And it is really poorly sampled. So we're using drones to fly up and down in those areas so that they can look at the ingredients for severe weather. We need to have moisture. We need to have changing wind speeds and wind directions with height to get things turning and moving. We have to have some way to lift up that air so it can cool and condense and form some big clouds and thunderstorms. So that area gives us a lot of information about if that thunderstorm is going to produce a tornado or if it's not. So that's why we're trying to put instruments around and near tornadoes. We don't have any vehicles that we drive inside tornadoes. We don't want to do that. That's bad. So we have vehicles that we take out to look at storms. We have mobile radars. We have mobile mesonettes, so we put our weather instruments on top of vehicles, and we take those out so we can look at storms. So there's lots of different tools that we use in addition to radar and satellite to look at severe weather. That's our specialty here because we're sitting right in Tornado Alley, so that's what we're known for here in Norman.
Very good. Let me see if somebody in Miss Powers' class there in Wisconsin there has a question for the very start of our tour. Anybody there? You guys want to ask a question?
I have a question. Okay, do you track hurricanes like at all, or tell us about that?
So we don't track hurricanes specifically here at the Weather Center. That's done by the National Hurricane Center in Miami, Florida. But if there is a hurricane that's near the U.S. coast and it's about to make landfall, sometimes the rain bands and sometimes the the eye wall of the hurricane can actually produce thunderstorms and tornadoes. So we have the Storm Prediction Center here in the National Weather Center. They issue all the severe thunderstorm and tornado watches for the lower 48 of the United States. So they'll be watching that and coordinating with the National Hurricane Center in case there's the threat for severe thunderstorms and tornadoes as those hurricanes are making landfall. But we do have researchers here that are specifically looking at researching hurricanes. So we have a lot of tropical experts that are here in our building too, not just severe weather experts.
And I saw one of our other classes was able to join us there. Is this Mrs. Malick's class there in Miller Intermediate School?
It's actually Miss Slovak's class.
How are you guys doing today?
Good.
Very good. Hey, does anybody there have a question as we get our tour started? Yes, sir. Go ahead. Speak up.
Does the National Weather Station have a severe weather plan? Like, what happens if the power goes out?
Very good question. So in case the power goes out or the network goes down, we have backup generators here in the building. We also have a power station northeast of the building, just to make sure that we can keep everything powered. And all of our weather service offices, including our national center, the Storm Prediction Center, they have backup offices just in case they happen to go down for any reason. So we always have plans in place to make sure that everybody can get all of their watches and advisories and warnings, and that there's no interruption in any of that. So we do have backup just in case.
And I wanted to show everybody, since we're inside the building, real quickly, I wanted to show everybody What's the outside of the building look like? Because it is actually a beautiful building. I've had the pleasure of getting to go there a couple of times for training. So it's a beautiful facility. Real quickly, does someone in Mr. O'Brien's class have a question?
Go up to camera. We do. We're sending a student out right now.
Is there a way to predict a tornado?
So
Yeah.
he's getting down to the nitty gritty there. So go ahead, Pat.
Yeah, I mean, there are ways to predict tornadoes, and we actually do a pretty good job of doing that too. The average warning lead time for tornadoes, for tornado warnings, is actually 13 minutes. But there are certain ingredients that we can look at in the atmosphere that hint at the potential for severe thunderstorms and especially for tornadoes also. So we do have the ability. I'll give you an example. May 20th of 2013, so about 5 years ago or so, there was a large, we were expecting large damaging tornadoes and a pretty big outbreak here in Oklahoma. And the people at the Storm Prediction Center were able to figure out the potential for severe weather all the way out to 7 days. So 7 days before those tornadoes even formed in central Oklahoma, we were already mobilizing emergency managers and city planners, police, fire, briefing, broadcast meteorologists. Everybody was getting prepared for that event 7 days before it actually happened. And then when the day came, we were watching what was happening in the environment. The National Weather Service was able to pinpoint that the storms were going to happen between 3 p.m. and 8 p.m. That's exactly when they happened. So we have a lot of really cool technology that allows us to predict with really good reliability the potential for tornadoes in an area. Now, not every thunderstorm produces a tornado, so sometimes we think that there's going to be large damaging tornadoes in an area, and it doesn't pan out. And sometimes that's because the conditions in the atmosphere just change a little bit from what we expected previously. But we can predict them with pretty good reliability.
So I got a picture of one of the tornadoes that was on the ground that day, and I know it did a lot of damage there in central Oklahoma. All right, Pat, we're going to let you go. He's going to run upstairs, and he's going to surprise us, either going to the Severe Storms Forecast Center or the forecast office up there. So why don't you go ahead and head on up? All right. So he's going to walk upstairs, and in the meantime, I'd be happy to answer any of your other questions. The facility there is a beautiful facility. I've gone there for training and learning more about the radar. So I was wondering there, Miss Powers' class, does anybody have a question about the weather? Go ahead.
What is the worst tornado?
Okay, you're going to have to speak just a little louder.
What is the worst tornado that ever,
So what is the worst tornado that ever occurred? It depends on how you measure that. It can be a couple of different ways, as far as the length, as far as the number of death tolls. It wasn't, we were thinking we were past the really, with the technology and everything, we were hoping that we were not seeing large death tolls in tornadoes. And unfortunately, with the Joplin tornado a few years ago, and also in Alabama, we had a tornado outbreak that killed over 100 people. We still see the importance of trying to get the word out, trying to get the message out. We can always do better. One of the worst tornadoes was called the Tri-State tornado. And let me see if I can find you some image. And it was way back in the 1920s. And as you can imagine, they call it the Tri-State tornado because it actually traveled through 3 states. It went through Missouri, it went through Illinois. I think it ended up in Indiana. So let me show you. They didn't, of course, no one had a picture of it then, back then, of the actual tornado. But what they did, they got lots of pictures of the damage. So let me show you my screen here. I forget the death toll from the Tri-State tornado. Off the top of my head, it was well in excess of 600 people. So definitely a devastating tornado. And I don't know if it's going to let me zoom in here. Okay, here we go. So you can see, I think that's a train that got blown over. But so you can imagine one of those big, heavy locomotive engines getting blown over by the tornado. So it was a devastating tornado. And I see Pat is back. Pat, where are you now?
Can you guys hear me okay?
Yes. Yes.
Okay, perfect. I am standing in front of the Storm Prediction Center. The Storm Prediction Center, this is the only storm prediction center in the United States. This group issues all the severe thunderstorm and tornado watches for the lower 48 of the United States. So every state except Alaska and Hawaii get their severe thunderstorm and tornado watches from this group that's here in this building, right in this office. A lot of people think the Storm Prediction Center is just this group of 1,000 people that are looking at severe weather and forecasting what's going to happen. But it's about 4 to 6 people, and they work rotating 8-hour shifts. So these people work from about 8 a.m. to 4 p.m. Then there'll be a new group that'll come in and work 4 p.m. to midnight. And another group's going to come in, they're going to work midnight to 8 a.m. So this office is staffed with people 24 hours a day, 7 days a week, 365 days a year, because you guys know that severe weather season runs from January 1st to December 31st. It's not just, April and May or June. It's all times of the year. So that's why this group exists, to make sure that you guys get all of your severe thunderstorm and tornado watches. So today's a little bit of a busy day. They've got an enhanced risk for severe weather in the Ohio and Mississippi River Valley area. So you can see there's a lot of things happening right now in this area. So I'll talk about all the different people that are here and the different workstations. So Joey over here, and then Ryan over here. They are kind of the first line of defense looking at severe weather here in the U.S. They're trying to pinpoint where conditions are favorable for severe thunderstorm and tornado development. So you can see they've got a lot of computers look at a lot of different types of weather information. So they're looking at radar, they're looking at satellites, they're looking at observational networks, so instruments that are giving them data and information. They're looking at different weather prediction models. We also launch weather balloons twice a day from different weather service offices. And those balloons give us observations at different heights in the atmosphere. And so you can see that we hand analyze those charts to give us an idea of what's happening at different levels of the atmosphere. And so this lets us know what the conditions are like, what the ingredients look like in certain areas. And we can put these pictures together with what we're seeing right now and kind of diagnose the potential for severe weather.
Hey,
so
Pat,
that's what these two folks are doing. Yeah.
Let me ask you, they have computers. Why are they drawing on paper like that? How does that help them?
Very good question, Tim. So you guys, if you don't know this already, you certainly will with all of your studies in school. You remember things a lot better when you write it down. So if you just try and read through something and try and memorize it, you're not going to remember it as good as if you were to actually physically write it down with a pencil, and you can see in this instance colored pencils and sometimes crayons also. This way, when they are looking at all of those different data sets on their computers, they have this picture in their head. And so this is giving them an idea of what the upper atmosphere looks like compared to what they're seeing down here closer to the surface, and then also with satellites too. So this really helps them in their forecasting because they have a physical picture in their mind of what the ingredients look like all the way up to about 100,000 feet or so. So these are really, really important to them. Now, so we've got the two forecasters here, left and right. And then the guy that's sitting underneath the red digital clock, he's kind of behind this other guy right now. That is John Hart. He is the lead forecaster. So if there's a severe thunderstorm or tornado watch issued between 8 a.m. and 4 p.m. today, there's a very good chance there's probably going to be severe thunderstorm and tornado watches today. He's going to be the one that's going to put those together and send it out to the people in those impacted areas. So he's got a really big responsibility. And actually, you can see they just issued one right here. Do you guys know how cool that was? You guys just actually watched a severe thunderstorm watch being issued from here. So John was actually putting that piece of paper together. He was giving it to the two forecasters, diagnose that. They're logging it right now. So you should see that pop up on here pretty soon. So you can see how the process works. John, right before we got here into this area, he was on the phone talking to the weather service offices that were in that particular area where they're about to issue that watch. They're having a little coordination call to make sure that everybody's on the same page. They know what to talk about, what they're looking at. So there's a lot of coordination that's done. You can see that he's got a special type of clock above his head that's called Greenwich Mean Time. It's a universally coordinated time so that we can collect weather information all across the globe at the same time. So that's why it's 5 hours ahead of what we would typically see right now here in Central Time. So those folks are kind of focused on what's happening right now, currently today. There's a guy, his name is Ryan. He's sitting over there in the left corner behind this giant pillar here. He is the outlook forecaster. So he's trying to figure out where the potential for severe thunderstorms and tornadoes exists all the way out to 8 days. You can see it there on that TV screen right there. So he puts together those little drawn hatched boxes so that you can figure out where the potential for strong hail and strong winds and tornadoes exists all the way out to 8 days. So he's putting those together so that you are well prepared in advance looking at severe weather. There's also a fire weather outlook forecaster that's here too to make sure that fire weather products get out to forestry officials and other groups. So this is a pretty dynamic office, but you know, what's really interesting is if there were 50 tornadoes on the ground right now, this office would look exactly the same as it does right now. Maybe they'd bring in 1 or 2 more people, but that would really be it. That would really be it. So this is it. And actually, I think they just issued that was a tornado watch that you guys just saw issued. So they just issued a tornado watch. So yeah, not only are you guys getting a tour of the National Weather Center, but you actually saw a tornado watch being issued right while you were doing this here. So, so pretty awesome. Yeah, they got that little red hatched area drawn out there. Actually,
hey Pat, I've got SPC's outlook for today up on the screen here. Can you kind of describe the colors that we see on this screen?
Yeah, I could definitely do that. And it looks like it was severe thunderstorm watch. I think it was down in Texas. So I got a little excited there with the tornado watch. I think it's severe thunderstorm watch. But so the graphic that you're seeing there on Tim's screen. So the different colors. So like I said, we have different ingredients that we look at in the atmosphere to figure out the potential for severe weather and how severe we're expecting it to be. So the Storm Prediction Center will, those outlooks that they issue will be for either a marginal, slight, enhanced, moderate, or high risk severe weather, depending on the hail threat, wind threat, and tornado threat for that particular area. So what you can see there in the map is we've got a little bit of all the types of colors that are up there right now. So you can see the darker green areas, that is the marginal risk. And then the lighter, the yellow areas, that's the slight risk. And then the orange area is the enhanced risk area. So they're expecting a lot of the big thunderstorms and the damaging and hazardous weather to be in those orange and yellow areas today and kind of on the periphery. So they're trying to pinpoint exactly where those things are. What those little boxes mean is that the potential for large hail, strong winds, and possibly tornadoes exists within a 25-mile radius around any point inside there. So if you were to draw a point inside any of those orange or yellow or green areas and go 25 miles all the way around in diameter, anybody in those areas could experience that type of weather for today. So that's how they put all that stuff together. So busy day today, as you can see. So you guys got to see an actual severe thunderstorm watch issued right in front of your eyes, standing in front of the Storm Prediction Center. That's what's really cool about this building. You saw the whole process right here.
Let me see if there's anybody got a question there in Miss Powers' class. Does anybody have a question in there for the Storm Prediction Center? They're measuring the tornado watches and everything. Yes.
What type of schooling do they have to do the work?
Could you speak just a little louder?
What type of schooling do the workers have to do to get into there?
So what kind of school do they have to go to?
In order to, if you want to work at the Storm Prediction Center or another National Weather Service office, most of the people that work in these positions are meteorologists. They are full meteorologists, which means you have to go to a university that grants degrees in meteorology or atmospheric science or earth science, something related to that. And it's a 4-year degree program. So you have to go through 4 years of college. And then you have the option, if you want to enhance your studies, if you want to get a graduate degree, then you can get a master's or a PhD in meteorology. And a master's is usually a couple of years extra, bachelor's, and then a PhD can be a few years and even a little bit more to get your doctor in philosophy in meteorology. So that's what you need, the kind of schooling you need to go through. A lot of the people that work in the place like the Storm Prediction Center and some weather service offices, definitely a lot of bachelor's, a lot of master's degrees, and some people actually do have PhDs also working in these weather service offices.
Good. Let me go over to our friends over in Ennis, Texas. Does anybody there have a question?
How do you calculate daily temperature?
So how do we calculate daily temperature, Pat?
So we have what we use to get temperatures, thermometers, just like you guys use. In order to get our temperature measurements, though, we're not taking those temperature measurements in direct sunlight. We're actually taking those measurements inside a shadowed box that's about 6 feet off the ground. So when we actually say the temperature is a certain degree, take into account that if you happen to be standing outside in the sun, in direct sun, that it's going to feel a lot warmer than our actual temperature. So we use thermometers in order to figure out what the temperature is. And the atmosphere acts like a fluid. So if certain conditions are in one place, we can use mathematics to figure out where those things are going to move to next. So we can anticipate, well, yesterday here in Oklahoma, we got up to, the middle 60s. And today, this cold front that's coming through, we have freeze warnings out for tonight already. And so we can actually kind of anticipate what the temperature is going to be like in certain areas by using math to figure out where that fluid is going to move to next, where those conditions are going to move to next. But we have a lot of different tools to measure temperature for us. Satellites even measure temperature for us. We can use satellites to look at the temperatures at the tops of clouds, see how cold they are, how much moisture is in those clouds. So there's lots of different tools that we can use to figure out what exactly the temperature is.
So this is on the screen is how we used to, and we still, some co-op observers still take temperatures this way. This is called a cotton region shelter. And there's a thermometer in there. Like Pat said, it's shaded from the sun. It has the little vents that let the air in. It always points towards the north. And we would go out and take the temperature. You'd go in there and you look, and you could see the temperature. We had 2 thermometers in there, one for the high and one for the low temperature. Now, these days, we're a little more fancy. We have digital thermometers and things like that. So we don't use those as much. But I do know that some of our co-op observers still use those cotton region shelters with the 2 thermometers in it, and they get our max and min temperature throughout, day in and day out. And they're the ones that give us a lot of great information.
Tim, we had one more thing we wanted to tell you guys. We just now got our notification from the National Weather Service for our watch today. So we were included in the watch that they just issued.
Oh, isn't that crazy? You guys saw where the watch was issued, and then you got it in your area. Isn't that crazy?
Wow.
Crazy.
Very good. And then
really
here,
cool.
I'll pull the watch up on the screen here in a second. I'll let Pat talk some more.
All right, so next area I'm going to show you, so this looks kind of similar to the other office that we looked at, the Storm Prediction Center, where the severe thunderstorm and tornado watches are coming from. This is the National Weather Service Norman Forecast Office. So there's 122 of these types of offices all across the U.S., including Guam and Puerto Rico. So our U.S. territories also have weather service offices as well. So Mr. Tim works at the El Paso office, so he's got certain counties that he's responsible and the folks there are responsible for looking after. This office is responsible for 48 counties in central and western Oklahoma, and then another 8 counties in western North Texas. So the people that live in Wichita Falls, Texas, and the surrounding area actually get all of their weather advisories, watches, and warnings from these folks. So basically everything except your severe thunderstorm and tornado watches are going to come from your local National Weather Service office. So if you get winter weather products or flooding products or those severe thunderstorm and tornado warnings, it's going to come from your local weather service office. And don't worry, you've got one just near you to give you all of that information. So in this room, you'll typically find about 2 to 5 people, and they work rotating 8-hour shifts, just like those folks at the Storm Prediction Center. But the difference is if there's a lot of significant or hazardous weather happening in the counties that they're responsible for, you're going to see a lot of people here in this office. So some people will have to work beyond that 8-hour shift that they just worked and work another 8-hour shift or longer. So there could be a lot of activity inside your local weather service office. So you can see that Mr. Tim's office looks pretty similar to this too. So they've got forecasters sitting around with their computer displays too. They have TVs in the back that's called their situational awareness display, so they can bring up a lot of different information. So that large screen on the left there has every advisory, watch, and warning currently for the U.S., so you can see where those are plotted. And look up there, so they're monitoring that cold front that's coming through Oklahoma right now, so you can see That's right over the top of us. If you can see outside, look at those trees whipping back and forth. So yeah, the cold front is definitely here, definitely windy. So they are watching that pretty closely. And we've got freeze warnings out for tonight, so they're watching and monitoring all of that stuff. What's really cool about having the National Weather Service and the Storm Prediction Center and all these different groups inside the National Weather Center is our students are taking classes here in the National Weather Center also. So if they want to volunteer at an office and learn how these people put together all this information, they get to come and volunteer in the office and figure out how everything works. So they get to interact with all these professionals. We also have a really cool space next to these offices. It's called the Hazardous Weather Test Bed. So we have researchers and scientists that are in here right now that are trying to figure out new ways to issue warnings and different forecast tools. So things that could eventually end up in an office like this one or the one over that we've just looked at, the Storm Prediction Center. Those new tools and products and warnings and techniques, they're all being developed inside this room here, this research to operation space. So there's just so many cool things here in the National Weather Center. So that is the local office of the National Weather Service. Like I said, you guys have one just like this in your area, issuing all of your different advisories, watches, and warnings.
So Pat, I got up on the screen a picture of the United States, and it has all the colors on there are different weather forecast offices. And you see there's like in California alone, I can't even count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 weather offices cover the state of California because it's so big. In Texas, it's about the same number. Other states are, since they're a little smaller, they're covered by one weather forecast office covers them all. But, everywhere from Caribou, Maine to San Juan, Puerto Rico to Anchorage, Alaska, Honolulu, Guam. I know that we even have some out in like Guam, out in the Pacific Ocean, that we all are working together. We focus in on that local area, and that's the important thing is that you've got the national centers like the Storm Prediction Center, and they're real good at doing the kind of the top-down, looking at the big picture, giving those watches and things like that. But it's the local knowledge at the weather office, like Pat was showing you right next door is the weather office for Norman. I'm here at the El Paso Weather Office. There's forecasters all across the country. Like I said, there's 122 weather forecast offices all across the country. They're staffed 24 hours a day, and their job is just simply to watch the weather, issue forecasts, but more importantly, to protect lives and property, to let everybody know, whether it's you, your teachers, your parents, when the bad weather is coming to town. And that bad weather takes many different forms depending on where you are in the country. On some days it can be a blizzard or really heavy snow. That can be very hazardous conditions. For us in the Southwest during the monsoon seasons, it's flooding rains. In the Midwest here, as they move further into April and May, it's going to be tornadoes and severe weather. Along the Gulf Coast, you mentioned, we had a question earlier about the hurricanes, tracking the hurricanes and then those impacts. So we all have our specialties. We're all focused in on a certain geographic area, and we try to make sure that we get the warnings and the forecasts out to everybody as best that we can. Hey, Mr. Pat, you're muted, but what you got there for us?
Yeah, so I took a quick walk downstairs to our vehicle bay area. So we're number one in the country in severe weather research and radar research. But really that shouldn't be surprising to anybody considering all the weather we get around here. Doppler weather radar started in Norman, Oklahoma. So we have a lot of really cool tools in order to take a look at severe weather here in the Central Plains and Southern Plains. We also have a large field experiment going on right now in the southeast part of the U.S. It's called Vortex Southeast. It stands for the Verification of the Origin and Rotation in Tornadoes Experiment. So we've got vehicles that are out there right now looking at those storms that are going to be popping up later this afternoon. So this is one of the vehicles that we use to get information about what's happening around tornadoes. You can see this is just a regular Dodge Ram. We have a hail-proof guard on here to make sure to protect the windshield and the rest of the truck. But on top of the truck, we put these instrument racks. So on top of the trucks, we have instruments to measure wind speed and wind direction and pressure and relative humidity. We even have GPS on top and RF antennas so that we can actually figure out where everybody is in the field experiment and then tell certain trucks, certain vehicles to move to certain areas if we want to look at certain parts of that storm. So we have one of these, And outside we have a Ford F-150. It looks just like this too. This is one of our scout vehicles. So we have regular SUVs that we'll send out, and these will kind of figure out good places for their storms, for the mobile radars and the mesonettes to set up, because we don't want to put them in a bad spot where they're not going to be able to see or move around very well. So we have these to kind of act as scout vehicles. We do a lot of mobile ballooning experiments. So we have giant balloons. This is actually one of our balloons here, kind of laid out. As you can see, this is not like the typical Weather Service balloons that are sent up twice a day. This is a 30-foot polyethylene balloon. We fill it up when we're out in the field, and we put it in this giant tarp. And then after we put it up in that tarp and fill it up, we attach a couple of instruments inside it to figure out what's happening inside the clouds. One of those instruments is this guy right here. This is a particle imager. So we'll send this up attached to the balloon, and you can see it's got a funnel here in the front. So as it's being carried up into the cloud, all of those different types of precipitation will fall through this funnel, and you can see there's a black background here. And then on the opposite side, we're going to put a high-speed imaging camera all the way down there at the bottom. And that's going to take a picture of the precipitation as it falls through, so we can watch it transition between rain and hail, and then it becomes ice crystals and snow and other things like that. So this is a way for us to figure out exactly what's happening inside those clouds, to look at all those different ingredients. So those are the couple of things that we have down here in the vehicle bay to look at severe weather, look at different types of weather. This is our play garage. We got all of our toys down here. It's really cool.
Hey, I tell you guys, you're getting a great tour. Pat is showing you things that I've been to the National Weather Center, and I've never got to go down into the vehicle bay. So that is a pretty cool thing. Let me go over to Mr. O'Brien's class there in Massachusetts. Does anybody have a question there? Anybody? Oh, here we go.
Why do tornadoes spin?
Oh, Pat, why do tornadoes spin? Why don't they just come down and sit?
Well, tornadoes are spinning because the winds in the atmosphere are spinning. So the wind speed and the wind direction that we have here at the surface is not the same as up 10,000 feet, as 50,000 feet, as 100,000 feet. There are different wind speeds and wind directions all over the planet because of the way that the Earth is the way that the sun is heating up the Earth, and then the Earth releasing that radiation and heating up certain places. So the Earth heats up differently, which causes differences in pressure, which creates the wind. And so the wind's not going to be the same in all places. Not every area has high pressure. Not every area has low pressure, which means you've got to move molecules from one place to another to fill in those areas with lower pressure. So we can have different wind speed and wind directions in all sorts of places, not just here at the surface, but higher up too. So when tornadoes form, we have a rapid increase in wind speeds and wind direction changes with height. And so that really gets stuff spinning. The difference between a regular, ordinary pulse thunderstorm that you might see in Florida that lasts 15 to 30 minutes or so, and a supercell thunderstorm, which can produce a tornado, is that it has a rotating updraft instead of a regular updraft carrying that air up. That rotating area of updraft is called the mesocyclone. And the mesocyclone is actually what's needed in order to create that tornado. So that is why tornadoes spin, is because there's a lot of changing wind speed and wind directions with height, and it all has to go back to the sun heating up the Earth unevenly in different places and creating changes in pressure, which creates the wind.
Very good. Let me real quickly. I'm going to show the severe thunderstorm watch that they just issued. So you can see for our friends there in Ennis, Texas, it is covering. Let me present this to everybody so you all can see it. But it is covering you guys, and like you said, it's pretty amazing with the technology now that they issued it. And then it takes just a few minutes to work its way through the system, but then you were able to get that on your cell phones as an alert. When I first started in the Weather Service, that was kind of the holy grail. I mean, I'd have people ask me, why didn't you call me and tell me that there was bad weather on the way? And I'm like, I can't call everybody. But now with cell phones, especially with the smartphones that we have, they provide us with an ability to reach directly to each person and give those warnings and those watches and get people alerted, because once you guys have the information, then you can make the appropriate action. You know, if it's a tornado warning, you seek shelter on the lowest floor of your home or your building, inside, away from any outside walls. If it's a severe thunderstorm warning, maybe you want to move your car into the garage. If it's a flash flood warning, you want to seek higher ground. And then all the other, we have all kinds of other different weather warnings. You know, in El Paso yesterday, we had a wind advisory for real strong winds. So people, we were telling people to tie the small items around that were in your backyard and in your front yard so they wouldn't blow around. All that information, we try to provide that information to you and your parents and the public so that they can make those wise decisions and try to prevent any, you know, damage or people getting hurt, or worst of all, anyone being killed. So let me go back up to our friends there in Wisconsin. Do you guys have any another question?
Alexa, why don't you go? Talk really loud, okay?
All right.
I stand right in front of the mic.
Why is it that you have to hide in a ditch when there's a tornado?
So you asked, you know, why do we need to hide in a ditch when there's a tornado? And here's what I'd recommend. If you don't have to do that, don't do that. We don't want you hiding outside when there's a tornado. If you're out in the country and you see a tornado, get to a well-built, sturdy building. If there is just nowhere else to go, the reason we want you to go out and get into a ditch is because a tornado, even if the tornado doesn't, you know, come right over you, many times a tornado picks up debris, whether it's pieces of the trees, whether it could be parts of a building that it's torn off, and it throws those all around. And if you're just standing there, I've seen pictures of 2x4s driven through walls and things like that. So what we don't want you to be is standing up just as a target for any of these, what they call missiles. And so we want you to be down as low to the ground as you can be so that you can avoid any of this flying debris. But if you can be at all possible, be inside a sturdy, well-built building, and that's probably the safest place that you can be during a tornado. What you got for us there, Mr. Pat?
So I took a little trip up to the observation deck. We've got a tour group that's in there right now, but I'm just a floor down from the observation deck, and I'm showing you guys here. This is our outdoor classroom space. So our students, when they are trying to learn about different weather instrumentation and how to use that and analyze the data from those instruments in the classes that they take, we have a lab downstairs on the 5th floor. But the problem is, if you're sitting in a lab and you're trying to take measurements of like wind speed and wind direction and temperature, you're taking measurements of the lab and you're not actually taking measurements of the atmosphere. And so that's why we have an outdoor classroom. This classroom is 150 feet off the ground and outside. So these posts that you see up here, these are the desks for our students. So they get to set up tripods with different weather instruments on here so they can learn how to use those instruments and analyze the data from them. There's a light with each one and also power. So if they have to come up here at night to take observations, they can do that too. The other thing we have up here that's really cool is we're working with the OU College of Architecture and OU Landscape Management, and this is our green roof project. So if you guys ever if you look at an aerial picture of a big city like New York or Miami or Chicago or Phoenix, LA, what you'll notice is on top of a lot of those skyscrapers, they have green roofs. And the reason they use those is because they can control their heating and air conditioning because they're absorbing that big sun up there. So when it gets really warm, instead of the tiles heating up really, really quickly, they have these planters that absorb that sunlight so the building doesn't heat up as much. And then in the wintertime, the sunlight that can be absorbed by these plots can actually be dispersed throughout the building. So it helps with heating and air conditioning. So you can see we have a whole bunch of native Oklahoma prairie grasses. You guys know our rivalry with Texas, right? We don't allow any Texas prairie grasses inside our plots up here on the rooftop classroom. So those are all native Oklahoma prairie grasses. And then these very front two planters here, this is our herb garden. So we're going to grow a variety of different herbs and spices up here. So hey, if the Flying Cow Cafe needs rosemary or thyme or basil or oregano, they can just come up here on top of the roof. It's all right here. They don't have to go to the grocery store. It's just growing on top of the roof of the Weather Center. So that is a classroom space. So if you guys come here, if you're students in our program, you actually get to go on the roof and take those observations.
That's so cool. What kind of research are they doing specifically, Pat? Are they doing severe weather research, or is it just, are they looking into thunderstorms or what?
Well, we have lots of different types of research that we work on. There are a lot of people that are looking at the impacts of large urban areas on weather and climate. So some people think that, you know, if you have a growing expanse of a city, if you have a lot of concrete and buildings, that's going to impact the local weather and the climate for that area. Because instead of having grass and landscaping and other things like that, you now have buildings and houses and that weren't there before. So they're looking at, you know, do these cities actually, you know, help produce thunderstorms in certain areas? You saw with Hurricane Harvey down in Texas from just a few months ago that when you increase the urban expanse, you put a whole bunch of impervious layers down by the surface there. So what happens is there's nowhere for the water to go. And so it ends up collecting in an area and flooding. So a lot of the research that we're doing with the rooftop classroom here is looking at urban impacts with weather and climate. So that's one of the things that we're really looking at. We can use this for severe weather too, so we can look at the conditions. Obviously the wind speed and wind direction are going to be different up here on top of the roof, above all the trees, than what you'd see down at the surface. We also do wind studies too. The reason we installed all of those native Oklahoma prairie grasses was because we did a 3D wind study of the wind that's around the building. And so the winds actually created a lot of pressure on those plants. And so we were able to actually figure out where we needed to plant those particular plants in order to protect the really sensitive ones that were sitting in the middle there.
Very good. That is so cool. They're doing all that kind of different research up there. Well, let me go over to our friends there in Miller Intermediate School to see if anybody's got a question there.
How often are your predictions wrong?
So how often are our predictions wrong? Never, never, ever, ever wrong. No, as you might imagine, we do get the forecast wrong every once in a while. So, but I would say that, you know, we get and it depends on how you kind of defined what's wrong. It's being off 3 degrees for a high temperature wrong versus 10 degrees being off the high temperature. We try to look at it and we try to be within 3 degrees of the high temperature, and 90% of the time we get the high temperature right. 90% of the time, you know, we're doing very good on getting when the rain is going to fall, when it's going to fall, where it's going to fall. And then the more challenging things are like what Pat's been talking about, trying to forecast where tornadoes are going to form. And you can't say exactly where a tornado is going to form until that thunderstorm pops up, but you can say an area where that tornado is likely to develop, and that's what the Storm Prediction Center is. That's what that severe thunderstorm, that tornado watch box. Then once the thunderstorms develop, they usually develop within those watch boxes, and that's what the local weather office, using radar and satellite, they can then pinpoint where they see that rotation developing, and then they can really narrow down where the impact from that tornado or that severe thunderstorm is going to be. So we're pretty good. You know, like Pat said, we have a lead time on tornadoes of 13 minutes. That means people in the path of the tornado have 13 minutes. And that doesn't sound like a long time, but it is if you got to get someplace safe. That gives you plenty of time to get all the pets in your house, get all the kids, put them in the lowest elevation, the lowest floor inside the interior walls of, you know, like a closet or a bathroom, and to get your head covered in some way to be protected from those tornadoes. It's plenty of time if you've got a car out to get it inside the garage, but you don't know it's not coming if the National Weather Service isn't issuing those warnings. Hey, Mr. Pat, what you got for us? Can you hear me, Pat?
Yeah, I can hear you. I'm outside on the roof. I wanted you guys to experience an Oklahoma cold front, so I'm going to round the corner here so you guys can experience this. I'll keep the mic on so that you can actually hear all the stuff. So I just wanted to give you guys a glimpse of what we deal with here in Oklahoma. So, and this will kind of be a little bit of a parting shot. I can hear that wind, right? Yeah, isn't that crazy?
You can hear the wind, but you can't even tell really that there's a cold front out there. But basically, a cold front is just that division from the cold air and the warm air. So cold air is moving into their central Oklahoma, and they're going to have a cold evening. Like they said, he's expecting freeze. I think they said they had freeze warnings out for parts of Oklahoma. Now, I know there for you guys up in Minnesota, or I'm sorry, Wisconsin and Massachusetts, you're still regularly having freezing temperatures. But I know for here in El Paso, we've passed the date of our last freeze on average that we get. So hopefully we don't get any more freezes. There in North Texas, I'm not sure when the date for the last freeze usually is, but we're getting to that season now where we're transitioning out of winter. We're transitioning into spring, which can bring some very interesting weather, as everybody knows, especially there in the Midwest, from North Texas up into Kansas, into Missouri, there along the Gulf Coast, in Alabama, Mississippi. It seems like they're always at a threat of severe weather. So again, it's the people there at the Severe Storms Forecast Center to be looking out either today or 7 days ahead of time to figure out where's the area that is most likely to form tornadoes and severe thunderstorms. And like Pat also mentioned, they actually do fire weather as well. So they coordinate with the weather offices. And I don't know if you guys realize this, but weather is very important when you're trying to figure out, is a fire going to start? Is it going to keep burning? And then once a fire is going, which way is it going to spread? So the Severe Storms or the Storm Prediction Center helps what local weather offices know when conditions are just right for the spread of wildfires, and then it's the local offices that issue those red flag warnings, letting people know that the potential for the fires are at the greatest. I know Mr. O'Brien's class has to leave, so we want to say goodbye to them. They are off to lunch. So you guys have a great lunch. Thanks for joining us on the tour today. We're just about to wrap up. You guys have done such a great job. You got one quick question for us?
One quick question, please.
Yeah.
How long do tornadoes last?
So what was the question again?
How long do tornadoes usually last?
Oh, very good. Mr. Pat, how long do tornadoes usually last?
Well, you know what? Most tornadoes really don't last that long at all. They might be on the ground for a minute or two or less. So that's why some people will be like, oh, well, it seems like it hopped over from, my house to the next person's house. Most tornadoes don't stay on the ground very long, but the ones that you typically see on TV, they'll show them on the ground for, 30 minutes, hours, several hours. So that is, so most of them are only on the ground for a short period of time, but then others can be on the ground for, several minutes, several hours. But most of them are just really short-lived.
And, I think Pat and the guys and gals down in the the Storm Prediction Center would be able to say, we've gotten to the point with the forecast, we're better at being able to forecast the days when we're going to have those short-lived tornadoes versus the days that we have those long track, deadly tornadoes. They've gotten the science. We've learned enough of the atmosphere where we can say this is a day where it's more likely we're going to see a long track damaging tornado, as opposed to another day which we could see tornadoes, but we're not expecting them to be real long track and real damaging kind of thing, right?
That's right. Yeah, it's a lot easier now to be able to predict really large outbreaks for tornadoes several days in advance. It's a little bit harder to pinpoint, if you have a cold front that comes through and the right ingredients are there for severe weather, sometimes you can get spin ups on those lines that can produce EF2 tornadoes, and they only last a couple of minutes or so. So those are a little bit harder to forecast, but those really big tornado outbreaks that can impact a lot of people, we're able to pinpoint that with really good accuracy several days out. And we actually have a researcher at the Storm Prediction Center right now that's looking at, large weather events and their predictability. And there was a large hail event back in the Denver area several months ago. And he analyzed that with a lot of different factors and was able to actually look after the fact. I know it was after the fact a little bit, so it's kind of like Monday morning quarterbacking, but he was actually able to predict that hail event in Denver 3 months in advance,
wow.
based on patterns of activity in the atmosphere and different teleconnections between larger global weather patterns. So we're just improving every day with our long-term forecast and also our short-term forecast too.
Very good. Now, we had a school that was supposed to join us from Iowa. And of course, they got snow in Iowa, so they had to cancel school. But the teacher just sent me a tweet, and she wanted to know how do we know when the storms are coming, and how bad are they going to be? And, I would tell her and her kids in her class, because they're in northern Iowa, they're having snow right now, but the weather offices there in and around Iowa and southern Illinois, or in Illinois, Iowa, Wisconsin, all right there. There are several weather offices that have weather radars. They can track the storms. They can see how strong they are. We use satellite. And then like Pat said, we just kind of know the conditions that are favorable on days when you have general thunderstorms versus days that you can have severe thunderstorms. And again, it's the people there at the Storm Prediction Center that help us to monitor that and get that word out. Get people, in the morning, if you know there's a chance for severe weather, you don't change your plans, but you kind of keep that in the back of your mind so that when thunderstorms start to pop up, it's not a surprise and you don't have to run around and do something real quick. You can say, you know what, I knew these were coming, and this is the plan that we had in place, and this is what we're going to do going forward. Mm-hmm. We're almost out of time. So real quick, I wanted to go one more time to our friends in Wisconsin. Do you guys have one last question? Here she comes.
Mm-hmm.
Okay, what was that? Real loud.
Do all tornadoes spin the same way?
So, hey, Pat, do all tornadoes spin the same way?
No, the answer is no. All tornadoes do not spin the same way. So most of the time, tornadoes will spin counterclockwise. So we call that cyclonic or counterclockwise. But you can have instances where tornadoes can actually spin clockwise or anticyclonic. And there can actually be instances where you have a tornado that's spinning cyclonically or counterclockwise and anticyclonically or clockwise happening within proximity to each other. But that doesn't mean that tornadoes are going to come together and create this one massive super mega tornado. So don't think that's possible. But we can have big tornadoes that can have little satellite tornadoes around them. But most of our tornadoes spin counterclockwise or cyclonically, and that has to do with the rotation of the Earth. So the rotation of the Earth is that same cyclonic, that counterclockwise, but there are instances where you can have clockwise rotation, which we call anticyclonic.
And here's a picture of what Pat's talking about. It looks like you have twin tornadoes, and these aren't two tornadoes. This is an actual picture from, I believe it was, I want to say Nebraska or South Dakota a couple years ago.
At Pilger.
Yes. Where was that?
Pilger, Nebraska.
So what happened is that a lot of times as one tornado is getting weaker, another tornado starts to form. It's just the environment that if the environment's right to form one tornado, it can usually start up a second one. So as one weakens, it's not uncommon to have another one start. And they just happened to capture this picture when they look pretty vigorous right there. So, but actually one of those tornadoes is beginning to weaken, and one of those was getting stronger when they took this picture. It's a very impressive tornado picture, but we've seen a couple of those happen. It's not uncommon as like I said, one storm is weakening, the tornado will get roped, kind of what they say is roped out real thin, and the other one just in the next thunderstorm over starts to strengthen and starts to get stronger. So one more question here, and then we will wrap things up. So we're back over to our friends there in Ennis, Texas at Miller Intermediate School.
What's the favorite part of your job?
So, Pat, I'll let you answer that, and then I'll answer it and wrap things up. What is your favorite part of your job?
What's my favorite part of my job? It's this stuff. Like, I get to teach people about meteorology. I get to do outreach for the Weather Center. Through the tours, I get to teach people about the building, about things in meteorology that they never knew before. So that's why at the beginning, when I was introducing myself and Tim mentioned I was the director of fun, I get to do all the fun stuff here at the Weather Center. And the field of meteorology is really cool. A lot of people think that you just, like, the only reason you're a meteorologist is to be on TV and stand in front of a green screen and tell people what the weather's like. But there's so many different careers that you could look toward with a degree in meteorology. You can be a fashion designer and a meteorologist. You could tell design companies when to release lines of clothing. You could be a weather detective, putting together weather information for insurance companies, clients, individuals. You can work for sports teams, providing lightning support for baseball stadiums, providing weather support for the Olympics and other stuff like that. There's just so many different careers in meteorology, so don't think of it as just having to be a broadcast meteorologist. There's lots of fun stuff out there to do, and weather is not going anywhere. So it's pretty good job security, because we're always going to have weather. We always need people to tell us what the weather is going to be like. So that's really the fun part of our job, is that we're a part of that small field of meteorologists that you don't get to interact with on a usual day-to-day basis. And there's always unending questions about our field, so it's never a dull day. We get to look at this stuff.
And for me, I enjoy, first of all, I really enjoy talking to schools and classes. So I really appreciate the opportunity to talk to the classes we have in the Hangout today, but also we had a whole bunch of classes joining us just live on YouTube. So I appreciate everyone who was able to watch. It's a great opportunity. I love talking to classes. And if you want your class to, a meteorologist to come talk to your class, you can send me an email at tim.bryce@noaa.gov, and I'd be more than happy to arrange a forecaster to talk to your class. The other part of my job is I really enjoy the challenge of doing the forecast, letting people know, what the weather is going to be so they can make those informed decisions. Do I need to wear a jacket today? Do I need to take an umbrella to work? Those seem like simple questions, but they make people's lives a little better. And then the important thing of my job is to let people know when the bad weather is coming to town. And I think that's real important. And people in the Weather Service all across the country take that very seriously. And we take it to heart that we're the front line, we're the first responders of that weather, and we try to get the word out as best as we can, as fast as we can, so that everyone can stay safe and make those informed decisions. Well, I really appreciate everybody joining us in the Hangout and also via YouTube Live. I'd like to thank Mr. Pat for taking us on the tour. Thank you, sir.
Yeah,
this was a
lot of fun. This was really fun. I'll give you one more top-down look from the National Weather Center. This is on the 5th floor of our building, looking down into the atrium area. So you guys get a little bit of a dizzying look down here to see our really cool building. Like I said before, if you've never been to Norman, Oklahoma, if the one reason to come to Norman, Oklahoma is to come see our building, make sure you guys come and see us.
Very good. Well, I want to thank Miss Powers' class there in Genoa City, Wisconsin for joining us. You guys did a great job. Good questions. And here's our other class over in Ennis, Texas at the Miller Intermediate Schools. You guys did a great job, and you're under a severe thunderstorm watch, so you powered through, so that was great. Again, my name's Tim Bryce. I really appreciate everyone joining us today. Thanks for joining us, and be looking for other tours and special events that we'll be doing with our special school outreach via video project. Pat, do you remember the acronym we came up with?
Yeah, it's CHARGE. It's Classroom Hangouts and Ask a Meteorologist using real-time group chat environments. I know that's a big acronym, but
I'm going to have to work on that. But thanks a lot to everyone for joining us today. It was a lot of fun. Bye-bye.
Bye.